The Inspire Dynamics cars have a full range of accessories for dynamics experiments. There are elastic bumpers, inelastic bumpers, small hook attachments, large hook attachments which go on the ends of the track. There are additional masses which fit onto the pegs on the cars. There is a pulley attachment with mass hanger and small masses and cord for use in a specific experiment. The large bumper and double-sided tape are used in crumple zone experiments. There's also an explosion bumper and hammer for triggering its action. The elastic bands and cord are for oscillation experiments. We have a linear track and a curved track. Each car has spring-loaded wheels, low friction wheels and magnets for attaching bumpers and other accessories. The primary car is marked with a P, the secondary car with an S. Pegs on the top allow you to attach additional masses. Indicator LEDs at the front and back are explained in the manual. The primary car communicates with a PC or tablet or smart device via Bluetooth. The two cars communicate via infrared sensors on both vehicles. Collision on a linear track. Elastic bumpers are fitted to the cars. And to the end plates of the track. Both cars are switched on. The blue LEDs flash. The cars are connected to the Timing Pro software. The flashing LEDs become steady. Click on Start Stop to begin the experiment. Push the primary car so it collides with the secondary car. Now we need to look at the results. Back.
Primary data has red headings. Secondary data has blue headings. Likewise, data is plotted in the graphs in blue and red. Data before and after the collision can be deleted, or the user can zoom in on the useful parts of the graph. We can remove the acceleration graph by clicking on the acceleration icon and in its place put the momentum graph. You can see that momentum before the collision and momentum after are the same. We can take away the momentum graph and put in an energy graph. The energy of the primary car, the energy of the secondary car are very similar. So when we click on summation, the black line is indicating the total energy at any time. You can see that energy is conserved during the collision.
Point there.
Yeah. Back. Back. Back.
The inclined plane. This standard experiment uses the primary car alone to investigate potential and kinetic energy. The linear track has a special block to raise one end and a built-in clinometer. The car is connected to the software. Clicking Start Stop begins the experiment. Moving the car from the bottom to the top of the track gives it some initial potential energy. Releasing the car allows it to roll down the slope, losing potential energy while gaining kinetic energy.
The primary car is used alone for this experiment. Connect the car to the PC, click Start Stop, then release the car from one end of the track. From the software, it is possible to measure the period of the oscillation. Run the experiment again with the car fully loaded with additional masses. Measure the period of the oscillation again. How does this relate to the motion of a simple pendulum?
Circular.
Oscillations can also be studied on the linear track. The primary car is used alone. Two strings of elastic bands are required and the hook attachments at the end of the track. Both chains of elastic bands are fixed to the car. With the car connected to the software, click Start Stop and displace the car either to the left or the right. Measure the period of oscillation from the software. Then repeat the experiment with the car loaded with additional masses. the oscillation appears slower. The software will tell you how much slower. Why is this different from the changing mass of a pendulum?